This video discusses colorimetry as an analytical technique for colorimetric biosensing using gold nanoparticles. If you enjoy watching this video, click on like, subscribe, the bell, and share so you can be notified of new videos that I post onto the channel. The analytical technique of colorimetry typically involves the measurement of changes in absorption spectra due to the adsorption of an analyte to the gold nanoparticles. It involves shining light through or onto a sample and looking at how much of the light is absorbed or reflected at different wavelengths. Colorimetry can provide qualitative or quantitative information, in which qualitative is noting the change of color by the naked eye, while quantitative measurements can be conducted via changes in the absorbance spectra using UV visible spectroscopy or by measuring the aggregation factor as a function of the bioanalyzed concentration. Quantitative measurements gives information on the limit of detection, limit of quantitation, and sensitivity of bioanalyses. This is an example of using UV visible spectroscopy to determine the concentration of human IgG that can be detection based on shifts in the surface plasmin band lambda max position. This is a semi-quantitative study since there is no calibration curve and limits of detection data. It is more precise than naked eye observations, but not as precise as obtaining limits of detection using a calibration curve. In this study, gold nanoparticles were used for the detection of human IgG protein. It was observed that there was a significant shift in the absorption surface plasmin band when 350 nanograms per milliliter of human IgG protein was added to the gold nanoparticles. It was also observed that at higher concentrations, such as 500 nanograms per milliliter of human IgG, there was significantly less aggregation that was observed. The graph shown here plots the change in the surface plasmin band lambda max position based on the raw data as a function of the human IgG concentration. It can be seen that there is an increase in the shift of the surface plasmin band lambda max up to 400 nanograms per milliliter. There is a dramatic reduction of the change in the surface plasmin lambda max position at 500 nanograms per milliliter and higher concentrations of human IgG. Dopamine functionalized gold nanoparticles are used for colorimetric detection of histamine. Limits of detection by naked eye, which is qualitative measurement, and also a quantitative method based on the calibration curve of the aggregation index as a function of the histamine concentration, is used to find the limit of detection of histamine quantitatively. Dopamine functionalized gold nanoparticles are used for the colorimetric detection of histamine, and the study involves looking at different concentrations of histamine from 1 ppm to 100 ppm. It was observed that there was a significant shift in the surface plasmin band lambda max position upon the addition of 100 ppm histamine, which suggests significant aggregation, and also the change in the final color of the solution. The underlying principle of aggregation index is that the color of gold nanoparticles changes drastically when they aggregate. The aggregation index of the gold nanoparticles was plotted as a function of the histamine concentration. It can be seen that the linear range is up to 10 ppm of histamine. The inset graph shows the calibration plot of the aggregation index as a function of the histamine concentration. Overall, the limit of detection for histamine was found to be 0.426 micromolar in a quantitative manner. Gold nanoparticles have also been used as colorimetric sensors for the detection of metformin, which is a very important biologically relevant drug used for treating diabetes. This method uses the UV visible absorption spectroscopy method for quantitative measurements of the limits of detection that can be achieved. Gold nanoparticles have been used for the colorimetric detection of metformin. It was observed that the surface plasmin band shifted from 525 nanometers to 645 nanometers due to aggregation of the gold nanoparticles upon addition of different concentrations of metformin. The results were quantified by constructing a calibration curve between 0 to 150 ppm. It was observed that the limit of detection was 1.79 ppm. There are several advantages and disadvantages of the colorimetric method for detection of biologically relevant analytes. Some of the advantages include the fact that it is a very rapid detection method and can also be visually with the naked eyes. For more accurate limits of detection, UV visible spectroscopy can be used to monitor the absorbance as a function of the concentration of the analyte. In addition, portable handheld UV visible spectrophotometers can be used for on-the-field analysis. There are also some disadvantages of using this method. The first is that it is not that sensitive and can only detect micromolar or part per million concentration range. If higher sensitivity and lower limits of detection are required, there are several other analytical techniques to choose from, such as fluorescence, surface enhanced Raman spectroscopy, ICP, mass spectrometry, electrochemistry, and many others. I will be creating videos on a wide variety of analytical techniques and applications of nanotechnology in different fields. Thanks for watching, and if you enjoyed watching this video, click on the like, subscribe, the bell, and share.